All right, last factoring lesson is factoring 1x² plus bx plus c, where we also have a front term here, a, so a number in front of x². I'm actually going to skip to the last page of your notes to start, just because it gives us a little bit more context maybe to get going. So we're going to factor by grouping today. So this works when we have 4 terms. The first group of pairs of terms that have a common factor, we're first going to group pairs of terms that have a common factor, and there is usually more than one way to do this. However, you will always get the same answer. And you're going to factor the greatest common factor from each group, and then we're going to factor the binomial common factor. So that makes no sense until we get started, so let's try it. So I have 6x² plus 4xb plus 15xy plus 10by. So you can see that we can't collapse any of these terms. And so what we're going to do is we're going to factor by grouping the first 2 terms and the second 2 terms. Now, technically, I'm going to take the positive for this 15xy. If I put the bracket there, it means they're separated by an addition statement, and there's no sign in front of 15xy, so we assume it is positive. Okay, so we always want to leave a positive or addition between the 2 binomials. Okay, so in our first binomial here, 6x² plus 4xb, we can see that both of those could be divided by 2, and each of them have an x. So we're going to write this as a 2x greatest common factor, and what's left will be 3x plus 2b. Now, in our second factor, we're going to be left with, if we take out a 5 and a y, those are the 2 terms that they have in common, we're going to be left with 3x plus 2b. Now, notice that the greatest common factor now between each of the terms, so the terms here are this and this, I could factor out the 3x plus 2b. What's left when I divide each term by that 3x plus 2b is 2x plus 5y. So note that the greatest common factors become the second binomial or the first binomial, it doesn't matter which order you take here, and the binomial that they have in common becomes the other one to factor. So again, we can double check our work here by expanding. So 3x times 2x is 6x². 3x times 5y is 15xy. 2b times 2x is 4b x, and 2b times 5y is 10by. A little bit of a different order, but the exact same polynomial here. All right, I just wanted to prove in B that it doesn't matter the order that we start with. So just erase this so it looks clearer. We have a 6x², a 6x², 4xb, 4xb, 15xy, 15xy, and 10by, 10by. So we're going to factor this, grouping the first 2 terms and the second 2 terms, leaving addition in between. So in our first term, we can take out a 4. Sorry, not a 4. My mistake. We can take out a 2b. So we're left with 2x plus 5y. In our second term, our second binomial here, we can take out a 3x. Oopsie, I don't need a bracket there. We can take out a 3x, and we'll be left with 2x plus 5y. We always want to try and get these two, like what's left of our binomials, to be the same. Okay, otherwise this doesn't work because, again, we're going to factor out the 2x plus 5y from both terms now, and we're going to be left with 2b plus 3x. Now, 2b plus 3x is the exact same thing as 3x plus 2b. I can write them either way. So it doesn't matter how we group them, they are the same thing. Okay, so we're going to double back to our factoring of ax squared plus bx plus c, where a is not 1, because 1 was what we looked at last time. What we need to do is find two numbers with a product of a times c and a sum of b. So this part is the same as last time. Now we just need to multiply a and c together, and then that'll help us decide what two factors to use. All right, so let's start with 2x squared plus 5x plus 2. Let's find out what the actual letters are. So a is always connected to our squared term, so that is 2. B is always connected to our x term, that's 5. And c is our coefficient, it's just a 2, or constant. What is a times c? Well, a times c is 4. And we need two terms to make the sum of b, which is 5. So that's a positive 4. 4 times 1 equals 4. And 4 plus 1 equals 5. So those are going to be our two terms. Now, rather than writing out our binomial and putting those two numbers in as the second piece, we actually have an extra step here. So what we need to do is we're going to break up our 5x term, and we're going to say that that's equal to 4x plus 1x, or just x, using these two factors. So 2x squared plus our 4x plus our 1x plus 2. We've, again, just extended our middle term here. Now what we can do is we have 4 terms. We can bracket the first two, bracket the second two, making sure that we're leaving an addition symbol between the two binomials, and we're going to factor out. In our first binomial, the common factor is a 2x. We're going to be left with x plus 2. In our next bracket here, there is no common factor between the two. So we say that that is just a 1. Both of these could technically be divided by 1. That's the only number. So x plus 2 remains. Now note that we have the same binomial in each case, so we're going to factor out that binomial, x plus 2 out front. What's left behind is our 2x plus 1. If we were unsure, we could foil this all out, and we would see that we get 2x squared plus 5x plus 2 as our final answer. Okay, next step, 3x squared minus 5x plus 2. So we get a is 3, b is negative 5 in this case, and c is 2. A times c, 3 times 2 is 6, and we need two terms that make the sum of b, so negative 5. What we know is that these two terms could be negative 3 times negative 2, because that equals positive 6, and negative 3 plus negative 2 equals negative 5. So we're going to expand our middle term here into these two. So 3x squared minus 3x minus 2x plus 2. Again, it doesn't matter the order of these. I could have put these in opposite if I wanted to and still would have come with the same answer. So in our first two terms here, and then we need our second two terms together. This one has a negative, so I need to put the negative into the bracket because that applies to the negative 2, and I'm going to add an addition symbol in between. It's really important to do this when there's a negative to start our second bracket, or any bracket for that matter. Okay, from here, we just go back to what we know. In the first bracket, there's a 3x as a common factor. We're going to be left with x minus 1. Don't forget that there will still be something there. 3x divided by 3x is 1. Plus, in our next bracket, we can see that 2 is the common factor. If I just factor out a 2, I'm going to be left with negative x plus 2. Plus 1, my mistake. So that looks somewhat similar. However, the signs are opposite. So what we need to do here is we need to factor out a negative 2. So if we factor out a negative 2, negative 2x divided by negative 2 is just going to be x. Positive 2 divided by negative 2 is negative 1. So by taking out a negative, we could make sure that our two leftover binomials here are the same, which is important. Okay, so we'll factor out those binomials. We get x minus 1. What's left is 3x plus negative 2, which is just the same as subtracting 2. The trick here again was to make sure that our negative stayed within our bracket. We had to add the positive, and then we take out a negative 2 to make sure our binomials are the same. Okay, looks a little bit different here, only because we have a y at the end. Okay, nothing's going to change about how we're factoring here. A is 3, B is 7, C is 2. We need two numbers that multiply to AC, so that is 6. Oh, sorry, A times C is 6, and we need to make add two numbers that add to 7. 6 and 1 are 7, and 6 times 1 is 6. So we're going to use those two factors. So I'm going to say 3x squared plus xy plus 6xy. Again, these two values add to our 7xy plus 2y squared. It hasn't changed. Bracket our first two terms, bracket our second two terms, leaving the positive in between. Common factor in our first set of brackets or binomial is x, so we're left with 3x plus y. In our second term or binomial here, the common factor is 2y, so we're left with 3x plus y. Noting again that our two leftover binomials are the same, so we're going to factor those out. We're going to get 3x plus y out front, and then times x plus 2y. So nothing's changed. When we had multiple variables here, we've done exactly the same thing. So summary of a decomposition method. What we've done is we've taken ax squared plus bx plus c. And we've said if we can find two numbers, g plus h maybe, that add to b, and g times h multiplied to a times c, we can break up the b term. So we can say that ax squared plus gx, my mistake. G times x plus h times x plus c, these are equal. And then we can group and factor. Find an integer to replace the blank so that each trinomial can be factored. How many integers can you find? So I know that a times c is 4 times 25. So a times c is 100. So I need two numbers that multiply to 100, and whatever they add to could be this integer in between. So numbers that multiply to 100, and we're going to find out what they add to. So 1 times 100 is 100. We also know that negative 1 times negative 100 is still positive 100. So 1 times 100 works, and 100 plus 1 is 101, and this will be negative 101. We can also have 2 times 50, or negative 2 times negative 50, if you've seen this trend here. These two numbers add to 52 and negative 52. I can have 4 times 25, or negative 4 times negative 25. So 4 plus 25 is 29, or negative 29. I can have 5 times 20, or negative 5 times negative 20. I can also have 10 times 10, or negative 10 times negative 10. So these are all the factors that could multiply to our negative 100. We're going to get positive 25, negative 25. I'm running out of room here. 20 and negative 20. Okay, so those are all the numbers that we could add to the blank. So 101, negative 101, 52, negative 52, 29, negative 29, 25, negative 25, 20, and negative 20. How many integers was that? Well, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 integers could work for this coefficient to factor our trinomial. There's a second one on this page, B. If you look at that, you should be able to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. B, there are 16 options. So see if you can find them all.